Okay, let's try this again. We have an introduction to equations today. By the end of the day, you'll be able to solve equations using mental math and tables. Yay! Okay, as a warm-up, we have this animal shelter and they want to raise $7,500. And we've got this table showing the results for the first 3 weeks of fundraising. Now the first step asks you to draw 3 thermometers. Oh wait, I have my laser pointer now. Okay, to draw 3 thermometers to represent the funds raised each week. I did that already. On our first week, we have negative $500, and then we have $500, and then we have $1,500 on our third week. So the question asks, why is week 1 negative? And there's plenty of reasons for that. If you're starting up an animal shelter, you're even starting up a fundraiser, you'll need to buy supplies to do your fundraiser. Maybe that's you're buying posters, or if your fundraiser is like a dinner, then you need to buy like the dishes, buy the food, you need to get stuff. You'll also need to advertise, especially if you want to get the word out. You want people to give you money. You need to advertise. That costs money. If you're hosting a dinner or something, you'll need to make a deposit. Or if you're renting out a space, you need to make a deposit on that. We call these guys upfront costs because you do them up front. You do them at the beginning. So these are called upfront costs. These are all reasons that you would be in the negatives when it comes to money. And then let's look at the pattern. What pattern do we notice? Well, I notice a pattern that for each week, as the week goes by, we're adding $1,000. So from week 1 to week 2, we add $1,000. And that same pattern continues. From week 2 to week 3, we add $1,000. We raise $1,000 more. We can assume that that pattern continues. So we add $1,000 each week. If we follow that pattern, we keep adding $1,000, when will the shelter reach its goal? Well, if you continue the pattern, you could make your own little table and say, well, after week 4, that's $2,500. After week 5, that's $3,500. Keep going those steps and keep doing those steps, and you realize that we will reach those steps in week 9. We'll reach $7,500 in week 9. So that brings us to a very important definition in algebra. We have a mathematical sentence that uses an equals sign. Remember, the equal sign looks like this. We call that an equation. An equation because it has that little equals guy inside. Equa meaning equals. If we wanted to model our warm-up with an equation, we could say that the funds raised, F for funds, is equal to negative 500. That's our upfront cost. That's how much we started with. And then for each week, we earn $1,000, 1,000 week, 1,000 per week. So it gives us F equals negative 500 plus 1,000 W. Now, why is this an equation? Well, it's an equation because it has an equals sign. There you go. A much more simple example of an equation would be 2 plus 3 equals 5. Why is this an equation? Well, it has an equals sign. That's why it's an equation. In fact, we can say that this is true. We can see we can look at an equation as a sentence. It's a math sentence. And a sentence can be true or false. So here we say that 2 plus 3 is 5. That's true because that is right. That's correct. So yeah, we can have a true statement. We can also have a false statement. An example of a false statement would be, for example, 2 plus 3 equals 6. That's not true. It's an equation, but it's a false equation. So there we go. That's a false equation. We have true and we have false. There's a third kind of sentence. We call this sentence an open sentence. An example of an open sentence would be like 2x plus 3 equals 6. This is an equation because it has an equal sign, but it's open because it has a variable. The variable makes it an open sentence. It might be true, depending on what x is. This could be a true statement. It could be a false statement. So we say this is an open statement because it depends. It depends on the variable. That's really hard to see how that yellow depends on the variable. Let's pick a different color. How about orange? Sticking with our color scheme. It's open because it depends on the variable. So let's look at these guys. Are they true? Are they false? Or are they open? And since we have short notes, I will go ahead and explain all the examples to you today. Here, example A. Is this true, false, or open? Well, 7 times 8, that's 56. And 56 is not equal to 54. So we say this is false. No, thank you. Let's look at B. It's an equation because it has an equals sign right here. Cool. 24 plus 18 is 42. And 20 plus 22 is 42. 42 is in fact equal to 22. Cool. We say this is true. And then look at C. It has an equal sign, so it is an equation. 2x minus 14, we can't simplify that. Is that 54? I don't know. So we say this is open. It depends on what x is. So who knows? That brings us to another term called a solution. A solution is what you get when you solve an equation, huh? Solution, solve, same kind of deal. It's anything that makes the equation true. Any value of the variable that makes it true. For example, if we look at 2x equals 6, it's open because we don't know what x is, but we want to find out what will make this true. And turns out if I plug in 3 here, if I plug in 3 for x, we get 2 times 3 equals 6. That makes it true. Awesome. So we say that the solution is when x equals 3. There you go. X equals 3 is the solution because it makes our statement true. Next, what do we want to plug in for p to make this true? Well, if we plug in negative 40 for p, that will make this statement true. Because 2 times negative 40 is 80, and 80 minus 4 is, 2 times negative 40 is negative 80, and negative 80 minus 4 is negative 84. So we say that when p equals negative 40, that's a solution. So negative 40 is a solution to the equation. You do not need to have one solution. You can have 0 solutions to an equation. You can also have infinitely many. You can have the number of solutions, totally depends. In this guy, we actually have we'll have 2 solutions. Because if I look at a squared equals 49, and I plug in, let's say, 7. If I say, okay, 7 squared is 49. That's true, awesome. So we can say that a equals 7. However, if I plug in negative 7 for a, that's still 49. Because negative 7 times negative 7 equals 49. Yay, it's true. So not only is a equal to 7, but also a equals negative 7. So this equation has 2 solutions. Cool. By the way, you can rewrite this as a equals 7 and negative 7. If you want to save time, that's great. You can even say a equals plus or minus 7. That's the same thing. Or you can say like a equals negative 7 and 7. Those are all fine. They all totally work. Okay. These are all the same thing. Okay. Now we want to figure out, so here we had to find the solution. Sometimes I'll ask, hey, is this a solution to the equation? Does this work? And let's find out. We want to see, is x equals 6 a solution to this equation? So what we do is we take x equals 6 and we plug it in here. The technical math term for this is substitute. So let's substitute 6 in for x and see what we get. That would give us 32 equals 2 times 6 plus 12 And because we're not sure, actually, we want to figure out, hey, is this true? We put a little question mark on it. So we substituted 6 for where x was. I want to see, is it true? So is it true that 32, is it, question, equal to, well, 2 times 6 is 12, plus 12, which is 24. Is 32 equal to 24? No, that is not true. So it's not, ooh, gross. So it is not a solution to the equation. Oh well, I'm sure someone still cares about it. All right, we have one more example, idea, thing. Shoot, no, we have 2 examples. Okay, that's great and all, but how is this going to help me in real life? Well, when we're looking at real world problems, how you know where to use equality symbols, we're looking for a very simple word. It's a linking verb, and it is. The word is helps us know, hey, that's where we want to put an equals sign. I should do like equals is equals. There you go. So whenever we see is, that'll tell us we want to put an equal sign there. So we have our friend Elizabeth, and she's going to make a model of the Mayan Great Ball Cart in Chichen Itza, Mexico. So we've got this sports court thing, like a basketball court, kind of. The length of the court, so if we have the length, that's 2.4 times its width. And then the length, and the width. We'll say the width is just width. And the length of her model is 54 inches. So what should the width of the model be? Well, I kind of already gave away the answer. The length, we'll say length is L stands for length, is, gives us an equals, 2.4 times width. And we'll say the width is W. So what we're doing here is we're translating from English into math. So we have this new sentence. We have, watch this, L equals 2.4 times W. I'm going to rewrite that down here. Oh, it says, hey, write an equation. Nice. We'll write it right there. L equals 2.4 times W. By the way, this times symbol is optional, so you can just do like this. If that's neater for you, that's great. Now where it says define the variables, we need to say, hey, what does L stand for? What does W stand for? So we say L is the length and W is the width. Ta-da! We also know that the length of Elizabeth's model is 54 inches. So because her length is 54 inches, we can substitute that in for L. Substitute in for L. So wherever we have our L, we're going to replace that with a 54. So we get 54 equals 2.4 times W. Now that we have our equation, we're going to plug in our samples here. It says, hey, what should the width be? We'll plug in each of these guys in for W and see which one is right. For example, if we plugged in A, that would give us 54. Is that equal to, question mark, 2.4 times 2.4 inches? Question, is it true? No. It's way off. It's not true. So no, that is false. Okay. Let's skip to C to save your time. 22.5. So we say, is 54 equal to, is it, question mark, 2.4 times 22.5? Yes, that ends up being true actually. So we substitute each, wrong tool, substitute each of our answers in for W, and it ends up being C. C is our correct answer. Awesome. So that's what we get. So that was how to use an equation to solve our problem. Now let's use a table to solve our problem. If we're trying to find a solution of 5n plus 8 equals 48. Again, we're trying to find our solution. We want to know what can we plug in for n to make it true. So we're going to plug in to make it actually equal to 48. So we'll try. We'll just pick a bunch of n's and we'll say, hey, if we plug it in to 5n plus 8, what do we get? And we end up with a answer. So we get 8, we get 13, we get 58. I'll walk you through those steps. So the reason I pick 0, 1, and 10 is because these are easy numbers. I'm going to start with easy numbers. It's easy to plug in 0 because we get 5. Oh, hey, laser pointer. Here it comes. Nice. Because we get 5 times 0 plus 8. That's easy to do. 5 times 0 is 0. 0 plus 8 is 8. But is that equal to 48? No, it's wrong. So, bummer. Okay. We try again. Let's try 1. We plug in 1 for our n. 5 times 1 is 5, plus 8 is 13. That's still not 48. Shoot. And you guys, look at the solutions we're getting, or rather, look at the results we're getting. 8 and 13, they are nowhere near 48. We need to try a much, much bigger number. How about 10? 10 is super easy. So we plug in 10 for n. 10 and n. It rhymes. Okay, Ben? Okay, again. 5 times 10 is 50. That's really easy to do. 50 plus 8, also easy, is 58. Oof, it's wrong. But it's not as wrong as earlier. So we know we're close. We know that 58 is close. So, that when we plug in n equals 10, that's close. So we need to pick a number close to 10, but not quite. We could do 7, for example. If we plugged 7 in, that would give us 5 times 7 plus 8. So we take our 7, plug it in for n. That gives us 35 plus 8, which is 43. Ooh, that's so close, but still not quite. Let's try one more. Let's go a little bit bigger. Let's give us 8. 5 times 8 plus 8 is 40 plus 8. And hey, that's 48. Yes, we got it. So our solution is this guy right here. So we say that n equals 8 is our solution. So there you go. I really hope the audio worked this time. If you have any questions, please ask. And have a great time finding some solutions.